Hi everyone and welcome to another video concerning vector mechanics. So today I'm going to be dealing with the concept of variable acceleration. So we're going to be dealing with the concept of differentiation calculus and integration inside vector mechanics. How do we do this? Let's learn all that in today's video. Alright, variable acceleration. So this is when the rate of change of velocity is not constant. In this section, we're going to discuss displacement, which we're going to present with r, velocity, which we're going to present with v, and acceleration, which I represent with a, and the relationship between them. So the displacement of a particle is the position of that particle relative to an origin point, and it is denoted as r. The acceleration of a particle is the rate of change of its velocity with respect to time, and it is denoted as a. It can be obtained by differentiating v with respect to time t once. So this is the way we can get acceleration. So acceleration can be equal to dv dt. So that's one way of finding acceleration. So similarly, acceleration a can be integrated once to calculate velocity v. So we can have v being equal to the integral of acceleration dt, as you can see right there. Then the speed of a particle is the magnitude of its velocity. It can be calculated as the derivative of the distance r. So you can have the speed v being equal to dr dt, and that is another way of finding velocity v. Similarly, the speed of a particle v can be integrated once to calculate the distance r. So we can have r being equal to the integral of v, as you can see right there. So above, we've listed down different formulas that we can actually use in this section of variable acceleration to solve all the different numbers. I encourage you to memorize the formulas in the yellow boxes, as they'll all be useful in this section. Alright, let's check some examples. So the first example is a question from UNEB 2002, and this was question number 8. So I've been told that a particle moves in the xy plane such that its position vector at any time t is given by r is equal to bracket 3t squared minus 1i plus bracket 4t cubed plus t minus 1j. Then I've been told to find its speed, that's part 1, and part 2, the magnitude of the acceleration after time t is equal to 2 seconds. So how are we going to solve this? So first of all, we've been given the position vector r being equal to that. So let's solve that. So I want to find its speed. Now from differentiation technique, we remember that v is equal to dr dt. So what we can do is we can actually differentiate this. So when you differentiate the value up, 3t squared minus 1 will have 6t. Then we differentiate this other value, we'll have 12t squared plus 1. So we shall have v being equal to bracket in column form 6t and 12t squared plus 1. Then let's look at the next section. So when t is 2, because we're now dealing with 2 seconds, so when t is 2, we'll have v being equal to 6 times 2, and then down we'll have 12 times 2 squared plus 1. So v shall be 1249, of which now I can find the magnitude of the speed, which is root of 12 squared plus 49 squared, of which I'll have it this way. So I have root of 144 plus 2401, which shall give me square root of 2545, which is equal to 50.448 meters per second, and that is the speed. Now, moving on to part 2, we're being told to find the magnitude of the acceleration after t is equal to 2. So how are we going to find acceleration? We can also use the differentiation technique, because now we know what the velocity is. Now remember that acceleration can be equal to dv dt. So this is what happens, is it means we can actually differentiate the value that we actually get here. We can differentiate the v here, and we can actually get acceleration. So when we differentiate this 60, we get 6. When we differentiate 12t squared plus 1, we'll have 24t. And now, because we're looking for when t was equal to 2, we're going to substitute that in, and this is what we'll have. 24 times 2 will give me 48. So I have acceleration as column 648, of which if I find its magnitude, I'll have the square root of 6 squared plus 48 squared, which shall be square root of 36 plus 2304, So I have square root of 2340, which is 48.3735 meters per second squared. And that shall be the magnitude of the acceleration of the particle after 2 seconds. Question 2. We're being told that a particle moves along a straight line such that after t seconds, its displacement from a fixed point is s meters, where s is 2 sin ti plus 3 cos ti. Find part 1 acceleration after t seconds, part 2 acceleration after pi over 2 seconds. Now in this example, instead of r, we've been given s as representing the displacement. So now every single case of how we would use r, we're going to use s in the same way. And then part 3, we're being told to find the magnitude of the acceleration after pi over 2 seconds. Alright, so putting the displacement in column form, I have 2 sin t, 3 cos t. Now for part 1, I want to find the acceleration after t seconds. So now there is a way of finding acceleration from knowing the displacement. So remember that v can be equal to ds dt or dr dt. But remember, in this case, we are having the s for all those cases where we would have used an r. So this is the same as the derivative of this, where I'll have at the top I have 2 cos t and at the bottom I have negative 3 sin t. Alright, but since I'm looking for acceleration, I also remember by differentiating this again, I can now find the acceleration. So again, from differentiation technique, I can find acceleration as dv dt. So I'm just going to differentiate this again, and then I'll have acceleration as, so this becomes negative 2 sin t, and this becomes negative 3 cos t. So therefore acceleration shall be, now I'm going to put it back in terms of I and j, it shall be negative 2 sin ti minus 3 cos t j meters per second squared. Now in part 2, we're being told to find the acceleration after pi over 2 seconds. Alright, so when t is pi over 2, I'm going to have it this way. So where there is t, I'm going to plug in pi over 2 in acceleration, and then I'll have a as being negative 2 and 0, which is the same as negative 2i meters per second squared. But now in part 3, we're being told to find the magnitude of the acceleration when time t is pi over 2, so I'm just going to find the magnitude. So now I'm going to plug this in, and I'll have negative 2 squared plus 0 squared, of which I'll have root of 4, which is 2 meters per second squared. And that is the magnitude of the acceleration when time is pi over 2 seconds. Alright, so moving on to question 3, we're being told that a particle moves along a straight line such that after t seconds, its displacement from a fixed point is s meters, where s is in column form sin 2t, t plus 1, and cos t plus sin t. So being told to find part 1, the velocity when time is pi over 2 seconds, and part 2, the speed when t is pi over 2 seconds. So again, here we've been given displacement in terms of letter s and not r. So wherever we've been using r, we're also going to use s in that way. Then part 3, acceleration after pi over 2 seconds. Alright, so in part 1, we know that from differentiation technique, we can find velocity from ds dt. So we're just going to differentiate the value of the vector that we get for displacement. So ds dt, and we'll have it this way. When you differentiate sin t, we'll get 2 cos 2t. Differentiate this, we have 1, and then differentiate this, and we'll have negative sin t plus cos t. So now we have v in vector form. So now that I know that, I can now plug in the time. So when time t is pi over 2, velocity will become this way. So if I multiply this 2 and this 2 cancel, and then I'll have 2 cos pi at the top, 1. Then these remain as they are. Now remember that cos pi is the same as cos 180, which will give me negative 1. So that's why I'll have negative 2 at the top. And then here this one remains as it is. And then cos pi over 2, which is the same as cos 90, this will give me a 0. Then here I'll have it as sin pi, which is the same as sin 90, which is positive 1, times this negative, I'll have a negative 1 right there. So therefore, putting that in terms of ijk, I'll have it as velocity being negative 2i plus j minus k meters per second. And that is what they wanted for part A. And then for part 2, they want speed when t is pi over 2 seconds. So therefore, speed is basically the magnitude of this velocity that we get right there. So we just have to find the magnitude of this. So to find the speed, we're going to have speed when time t is pi over 2 being equal to square root of negative 2 squared plus 1 squared plus negative 1 squared, which shall be root 6, which shall give me 2.45 meters per second, and that is the speed when time is pi over 2 seconds. Now for part 3, we're being told to find the acceleration after pi over 2 seconds. Alright, so that part 3, when time t is pi over 2, we know from differentiation technique that acceleration is dv dt. So now we're just going to differentiate that value of velocity that we had actually gotten. And that is this value right here. So when you differentiate this, we'll have acceleration shall be negative 4 sine 2t, then we'll have a 0 here, then we'll have negative cos t minus sine t. Alright, so next, when time t is equal to pi over 2, this is what I'm going to have. So when I substitute the value pi over 2 to where we have t, so now this 2 and this 2 will cancel, and then definitely at the top I'll be remaining with negative 4 sine pi. And as you can see right here, now sine pi, which is the same as sine 180, is actually 0. So I'll have a 0 at the top. Then right here, sine pi over 90 is the same as, sine pi over 2 is the same as sine 90, which is actually 1. So I actually have a 1 right there. Then cos 90 is going to be 0. So I'll have 0 right here. So that means I'll be left with negative 1 at the bottom. So I'll have, so the end acceleration shall be 0, 0, negative 1, which is the same as negative k meters per second squared. And that is the value of the acceleration. Alright, so the next is a question from UNEB 2001, and this was question number 13. So being told that an object of mass 5 kilograms is initially at rest at a point whose position vector is negative 2i plus j. So being saying that if it is acted upon by a force F, which is equal to 2i plus 3j minus 4k newtons, find part 1, the acceleration, part 2, its velocity after 3 seconds, and part 3, its distance from the origin after 3 seconds. So now this question is a little bit different in that we've been given a mass. So we've been told that a mass, and we're being told the force that it is acted upon by. So that actually means that to find acceleration this time, we don't even need to use these differential techniques that we've been using. This one is actually straightforward. We can just use Newton's second law. So that shall actually be F is equal to ma to find acceleration. So acceleration can be found from Newton's second law of motion, so which is F is equal to ma. So you can have it this way. So acceleration is F over m, of which we know the force and we know the mass. So you can have it this way. So we shall have this force here dividing the mass, which is 5 kilograms. That's why we have 1 over 5 times that. And therefore the acceleration is 1 over 5 into 2i plus 3j minus 4k meters per second squared. So now we have the acceleration. So in part 2, we're being told to find its velocity after 3 seconds. So now for velocity, because we know the acceleration, we can now use the integration technique to find acceleration. So we know that from integration technique, we can find v being equal to the integral of acceleration dt. So we're going to have the integral of that. So now I've placed it in column form for that purpose. So now when I integrate this, each of the values here, so as you can see, this 1 over 5 is the constant. I can just place it out. So here I will have this will become 2t, this will become 3t, and this will become negative 4t. 1 over 5 times that plus c. Alright, so the next step is to find the value of c, and we can only find the value of c by looking at the point where time was 0, or where we were at the initial beginning. So as you can see, this particle begins from rest, so it actually means that the velocity at the very beginning was 0. So let's look at that point. So at the start, when t is equal to 0, v is 0, 0, 0. So you consider it this way because this is actually a 3-dimensional vector. So we're going to have 3 different parts for the zeros. So this is what we can have. So substitute that in and we'll have it this way. So where there is v, we have 0, 0, 0 being equal to 1 over 5 into 2 times 0, 3 times 0, negative 4 times 0 plus c. So when I multiply those, I have zeros all over. So I can see that what I'll be left with c being equal to 0, 0, 0, because this times these zeros also gives me a 0. So c shall be equal to 0, 0, 0. So now, therefore, v shall actually be equal to that, because where there is c, it's definitely 0. So this remains the value of v. So now, we're going to look at the point where time is 3 seconds. So we're going to plug that in where there is a t. Then, this is what we have. We have 1 over 5 times 6, 9, negative 12, of which I'll have it as 1 over 5 into 6i plus 9j minus 12k. Now basically I can pull out a 3 from the inside because that's what they have in common. So therefore my velocity shall be 3 over 5 times 2I plus 3j minus 4k meters per second. Alright, so in part 3 we're being told to find its distance from the origin after 3 seconds. Alright, part 3. So now from integration technique we also know that displacement r is equal to the integral of velocity. So we know the velocity, so we can actually find the value of r. So now when we place in the value of the velocity is actually the same as this. Now good enough, we know that velocity is 1 over 5 into 2t, 3t and negative 4t. So this is what we're going to plug in. So now we'll have r being equal to that. So when we actually integrate this, we'll have it this way. So 2t becomes t squared, and then this when integrated, 3t when integrated will become 3 over 2t squared. The negative 40 when integrated will become negative 2t squared times this 1 over 5 plus c. So now the next step is to find the value of c. So good enough, according to the question, we're being told that when the particle was initially at rest, it was at the point whose position vector is negative 2i plus j. So we know the initial position vector. So at the start when t was 0, r was negative 2i, and then the coefficient for k was 0. So that means we actually just place a 0 there. So we're going to have this being equal to that. So wherever we have a t, we're just going to place a 0, and then this is what I'll have right now. So this times this gives me a 0, and then I have c as being equal to negative 2, 1 and 0. So now therefore r shall be equal to 1 over 5 into t squared, 3 over 2t squared, negative 2t squared plus this value of c that we've actually found right there. Alright, so when I add these two brackets, I'll have it this way. So first of all, make sure to first multiply the 1 over 5 into this. So that's why I have this top one as t squared over 5, this as 3t squared over 10, and this as negative 2t squared over 5. Then add the values on the other side. So this will be minus 2, this will be plus 1, and then this will be plus 0, which is actually just, we're going to have it by itself. So I'm going to have this. So when t is 3, because we've been asked for the displacement when t is 3, we're going to have r being equal to that. So now when we solve this, we're going to have 9 over 5 minus 2 at the top, 27 over 10 plus 1, then negative 18 over 5, of which I'm going to have it this way. So my answers are negative 1 over 5, 37 over 10, and negative 18 over 5. Alright, so next, to find the magnitude of distance from origin after 3 seconds, this is what I'll have. So finding magnitude will be the square root of this squared, and that squared, of which I'll have root of 0.04 plus 13.69 plus 12.96, which shall be equal to root of 26.9, which is 5.1662 meters. And that shall be the distance from the origin after 3 seconds. Alright, so the next question is a question from UNEB 2014, and this was question number 2. So being told that a particular car starts from rest at the origin 0, 0. Then we're being told that its acceleration in meters per second squared at time t seconds is given by a is equal to 60i minus 4j. So being told to find its speed when t is 2 seconds. So now for this question, we've been given acceleration as 60 and negative 4. So from integration technique, we can actually use it to find the speed. So we know that we just have to integrate the value of acceleration. So we shall have it this way. So when I integrate this, this is what I have. I'll have, so for this I'll get 3t squared, and then for this I'll get negative 4t plus c. So now the next thing is to find the value of c. So that means I'm going to look at the start when t was 0. So at the beginning, we know that since the particle was at rest, it means that the velocity was 0, 0. So we're going to substitute that there, and we'll have it as 0, 0 being equal to that. So where there is t, we're actually going to put 0, then plus c. So c shall actually be equal to 0, 0. So after that, now to find c, we can plug it in, but since it's 0, that means we just are left with just this. So have v being equal to 3t squared negative 4t. So now when time t is 2, we're going to have it as v being equal to, now 3 times 2 squared, which is the same as 3 times 4 is 12, negative 4 times 2 is negative 8. So I have v is being equal to 12 and negative 8. Now I can now find the speed. So now, remember, speed is the magnitude of velocity. So that means we actually have to find the magnitude. So now it's going to be the square root of 12 squared plus negative 8 squared, which is root of 208, which is 14.422 meters per second. And that is the answer we're looking for. Alright, so the next question is a question from UNEB 1995, and this was question 8b. So being told that a particle of mass 2 kilograms, initially at rest at 0, 0, 0, is acted upon by the force 2ti plus tj plus 3tk newtons. Now I'm being told to find the acceleration at time t. Part 2, find the velocity after 3 seconds, and part 3, the distance traveled after 3 seconds. Alright, so now we've been given the mass as 2 kilograms, and then we know that the force that's acting on it, so we can actually find the acceleration from Newton's second law of motion, which is F is equal to ma. So if we make A the subject, A shall actually be equal to F over m, so I'll have it this way. So it will be like a half times this value right here. So this is what I have. So therefore, acceleration shall be equal to a half into 2t 3t meters per second squared, and that is the answer for acceleration at time t. Since we are not given a specific time in part 1, we're just going to leave the t as it is. Now for part 2, we're being told to find the velocity after 3 seconds. Now you know that you find velocity by integrating acceleration. So from integration technique, I can have v being equal to the integral of acceleration. So when I put that in, what I'll have is this. So this 2t will give me 2t squared over 2 when I integrate it. Then this t will give me t squared over 2. Then 3t will give me 3t squared over 2. So now this is what I have plus c. Alright, so next I can actually say that each value here actually has a half in common. So I can actually pull out a half. Then we'll have this a half times this a half that we actually have outside. So a half times a half will give me 1 over 4 into 2t squared, and 3t squared plus c. Alright, so the next step is to find the value of c. So that means we have to look at the start when the value of time was 0. So at the start when t is equal to 0, we can say that since the particle was initially at rest, it means that the value of v was actually 0, 0, 0. So that means this is what we'll have right now when we plug it in there. So now multiply this to 0 and we'll be left with 0, 0. So eventually c shall actually be equal to 0, 0, 0. So that means that velocity shall actually be equal to only this side right here, which is v equal to a quarter times this, as you have it right there. So now that we know the value of v, we can now look at when time t was 3. So we can plug in the time 3, and this is what we have. So we shall have a quarter times 18, 9, and 27, which is a quarter times 18i plus 9j plus 27k meters per second, and that is the velocity when time is 3 seconds. So in part 3, we're being told to find the distance traveled after 3 seconds. So for part 3, from integration technique, we know that the distance r, or displacement r, is equal to the integral of v. So now, good enough, we know what v is. This is the value of v, so we're just going to plug it in. So this is what we have right now. So when you integrate that, integrate this 2t squared and you have 2t cubed over 3. Integrate t squared and you have t cubed over 3. Integrate 3t squared and you have 3t cubed over 3. As I can already see, I can actually extract out a third from there. And I know a third times 1 over 4 will give me 1 over 12. So I'll have r as 1 over 12 times that. So at the start when t is equal to 0, we've seen that this particle begins with initial position vector 0, 0, 0. So that's why we have it as 0. So now we're going to have 0 being equal to 1 over 12 times that. So this times this will actually be 0, so I'll remain with c being equal to 0, 0, 0. So that means that r shall actually be equal to only this side right there. Alright, therefore when t is pi over 3, I'm going to plug in a 3 wherever there is a t. So this is what I'll have. So multiply everything inside and convert them into ijk, and this is what I'll have. So next I'm going to multiply the 1 over 12 inside because I need to find the distance. So now I have 9 over 2i plus 9 over 4j plus 27 over 4k. So to find the magnitude of the distance from origin after 3 seconds, I'll have it this way. So now square everything, and then I'll have the square root of 70.875, which is 8.42 meters. So therefore the distance traveled by the particle after 3 seconds is 8.42 meters. Alright, so the next question is a question from UNEB 2019, and this was question 12. So I've been told that a force F being equal to 2ti plus j minus 3tk newtons acts on a mass 2 kilograms. So the particle is initially at a point 0, 0, 0 and moving with a velocity I plus 2j minus k meters per second. Determine the magnitude of the acceleration of the particle after 2 seconds. That is part 1. Part 2, the velocity of the particle after 2 seconds. Part 3, displacement of the particle after 2 seconds. So let's first solve part 1. So we need to find the magnitude of the acceleration after 2 seconds. So first of all, we've been given the force acting on the particle and we know the mass is 2 kilograms. That means we can use Newton's second law of motion to find the acceleration. So we know that F shall actually be equal to ma. Make A the subject. A shall be F over m, of which it's the same as a half times this value right there. So therefore, when time t is equal to 2, because we've been told the acceleration and the time, this is what I'll have. I'll multiply that in and I'll have it as 1 over 2 into 4, 1, negative 6. So this is what I have. Multiply the half inside and I'll have 2, 0.5, negative 3. So now next, remember that we are being told to find the magnitude of that acceleration. So we need to find its magnitude. So the magnitude of that is square root of 2 squared plus 0.5 squared plus negative 3 squared, which is root of 13.25, which is 3.64 meters per second squared. So therefore that is the magnitude of the acceleration of the particle after 2 seconds. Alright, so for part 2 we're being told to find the velocity of the particle after 2 seconds. So good enough, velocity is actually the integral of acceleration. So we know the acceleration as we actually have it right here. So we're going to plug it in. So we're going to have v being equal to the integral of a half into 2t 1 negative 3t. So now when I integrate this, 2t will give me 2t squared over 2. This 1 will become t, and then negative 3t will become negative 3t squared over 2 plus c. So now this is what I end up having. So negative 3t squared over 2 is the same as negative 1.5t squared. Then this 2 and this 2 cancel and I'll be left with t squared plus c. Now in the question we are told that the particle is initially at a point 0, 0 and moving with a velocity I plus 2j minus k. So that means that this is actually the velocity when time was actually 0. So this is what we shall be using. So at the start when t is equal to 0, v shall actually be equal to 1, 2, negative 1. So plug that in. Then we're going to have that as being equal to this as we have here. So where we have t, we're going to put 0 as you can see right here plus c. So we're going to have c being equal to 1, 2, negative 1. So therefore v shall actually be equal to a half times this, then plus the c, which is now equal to that. So now the next thing is I can multiply the half, first multiply the half into the values right there. Then this will, at the top will give me t squared over 2. This will give me a half t, and then this will give me negative 3t squared over 4. Then plus the values on this side. So I have at the top plus 1, then next I'll have plus 2, and then this, because this is a minus, I'll have it as minus 1. So we look at when time is 2 and we're going to plug that in to find the value of v at that point. So now when I plug that in, this is what I have. Simplify that further, and then this is what I end up with. Now 4 divided by 2 is 2, 2 divided by 2 is 2, is 1, and then 12 divided by 4 is negative 3. Negative 12 divided by 4 is actually negative 3. So this is what I have now. 2 plus 1 will give me 3, 1 plus 2 will give me 3, and negative 3 minus 1 is negative 4. So therefore, the velocity v when time t is 2 seconds is 3i plus 3j minus 4k meters per second. And that is the answer they wanted. Now in part 3, we're being told to find the displacement of the particle after 2 seconds. Now also pay attention that the particle is initial at a point 0, 0. So that's all going to be important. And also it's important to remember that our value of v was this value we have right here. And why is that important? It's because from integration technique, r shall actually be equal to the integral of v dt. So I'm actually going to plug that in as you can see right there. So this is the value of v that we got. So we're going to integrate that. So in integrate this, I'll have, for the top, I'll have t cubed over 6 plus t, and then this will give me t squared over 4 plus 2t. Then this will give me negative 3t cubed over 12 minus t, as you can see right there, plus c. Now this is what I have as the value of r. But if we want to find the value of c, we're going to look at the start when t was 0. So remember, since the particle was beginning at the initial position 0, 0, 0, so we know the value of r. So we're going to put r right there being equal to this, where there is a 0 where we have t plus c. So you can see that c shall actually be equal to 0, 0, 0. So that means that therefore r is equal to that. So now when t is equal to 2, I'm actually going to plug in a 2 where there is the value of t. So I'll have this value. So add that together and I'll have 10 over 3, 1 plus 4 and negative 2 minus 2, which will give me 10 over 3, 5 and negative 4, of which r shall be 10 over 3i plus 5j minus 4k meters, and that is the answer they wanted. So the next question is a question from UNEB 2017, and this was question number 10. So being told that a particle of mass 3 kilograms is acted upon by a force F, which is 6i minus 36t squared j plus 54 tk newtons at a time t. So being told that at time t is equal to 0, the particle is at position vector I minus 5j minus k, and its velocity is 3i plus j meters per second. So being told to determine the position vector of the particle at time t is equal to 1 second. Then part 2, the distance of the particle from the origin at time t is equal to 1 second. So let's solve that. So as you can see, from Newton's second law of motion, we can actually first find the value of acceleration, since we know the force acting and we know the mass. So we're going to have F being equal to ma, of which A shall actually be equal to F over m. And then A shall actually be equal to a third times this value right here. So this is what I have right now. So when I multiply the third inside, I have 2i minus 12t squared j plus 18t k, as you can see right there. So I now know the acceleration value. Now that I know acceleration, I can use integration technique to find the value of v. So now v, remember, is the integral of acceleration. So now v shall actually be equal to that. So put this in, and this is what I have. So integrating that, I'll have this will give me 2t, this will give me negative 4t cubed, and then this here will give me 490 squared, as you can see right there. So now, very important things to remember from the question. We're already told that at time t is equal to 0, the particle is at position vector that, and its velocity is this. So we know the initial velocity when t was 0 is that. So now to find the constant c, we're going to have to look at the point when time t was 0. So at the start when t is equal to 0, we can say that v is 330, of which the constant where there is k is 0, as you can see right there. So therefore this is what I end up having. Then c shall actually be equal to 330. So that means that v is equal to that. Now the next step shall be for me to add the values. So when I add them, this is what I get as the value of v. Alright, so next, to find the position vector, I know that r shall actually be equal to the integral of v, of which it shall be equal to that. So when I integrate this, I'll have t squared plus 3t. This will give me negative t power 4 plus 3t. Integrating this, I'll get 3t cubed plus c. But now that I have that, I can now also find the value of constant c. So I have to look at the origin. Now we're already told that the initial position was 1, 5, negative 1 as r. So plug that in, and this is what I have. So when I solve that, I'll find c as being equal to 1, negative 5, negative 1. So that means that the value of r is equal to that. So now add the 2, and this is what I'll have. Now being told that we have to find that position vector when time t is equal to 1 second. So I'm going to place a 1 where there is t. Then when I multiply everything, I'll have at the top 1 plus 3 plus 1. Next line I'll have negative 1 plus 3 minus 5. Then next line will be 3 minus 1, which will give me 5, negative 3, 2. So therefore the position vector when t is 1 second is 5i minus 3j plus 2k. And then next, we're being told to find the distance of the particle from the origin at time t is equal to 1 second. So now that we know the position vector, we can actually now find the distance. So for part 2, to find the magnitude of the distance from origin after 1 second, I'll have it this way. So I have the square root of 5 squared plus bracket negative 3 squared plus 2 squared, which is root of 38, which is 6.164 meters. And that is the magnitude of the distance from the origin after 1 second. That is what they wanted. Alright, so the next question is a question from UNEB 2016, and this was question number 13. So being told that a particle starts from rest at a point 2, 0, 0 and moves such that its acceleration at any time t is greater than 0 is given by A being equal to bracket 6 cos 4ti plus 8 sin 2tj plus into bracket sin t minus 2 sin 2tk meters per second squared. So we know the acceleration. So I'm being told to find the speed when t is pi over 4 and the distance from the origin when t is equal to pi over 4. Alright, so for part 1, we've been given the acceleration. So that means we can actually first find the velocity, and we know from integration technique we can actually find the velocity v, which is the integral of acceleration. So now plug in the values of acceleration there, and this is what we have. So when you integrate those values inside, I'll have 4 sin 4t, negative 4 cos 2t, and negative cos t plus cos 2t plus c. Alright, so the next part is to find the value of the constant c. So that means we're going to look at when time t was originally 0. Now since the particle was initially starting at rest, it means that the velocity of the particle was initially 0. Alright, so next you're actually going to put a 0 wherever there is a t, and then where there is v, you're actually going to place 0, 0, 0, as you can see right. As you can see here, sine of 0 is actually going to give me a 0, so that means we're going to have 0 at the top, and cos of 0, because 2 times 0 is 0, is 1. So I have a positive 1 times negative 4. So actually, this is what I'll have right there. So I'll have 0, 0, and then I'll have 0, negative 4, negative 1 plus 1, which is actually equal to 0. Now next, to make c the subject, we actually take these values to the other side, of which this negative 4 will become a positive 4. So that means I'll have c being equal to 0, 4, and 0 when we take these values to the other side. So therefore v shall actually be equal to the column 4 sin 4t minus 4 cos 2t minus cos t plus cos 2t plus 0, 4, and 0, as you can see right there. So now this shall actually be our value for velocity. So now that we know the value of velocity, we can look at it when time t is equal to pi over 4. So plug those in, and this is what we have. So now you can see that this and this cancel, and I'll be left with 4 sin pi at the top. Then down here I actually see that this 4 and this 4 reduce, these 2 reduce, and I have negative 4 cos pi over 2 left plus 4. Then here I'll have negative cos pi over 4 plus cos. Then this and this also reduce, this also become cos pi over 2 right there. So now this is what I'll have after that. Alright, and next I know that cos pi over 2 is the same as cos of 90, so this becomes 0, and I'll be left with negative cos pi over 4. So this is what I have right now. So that shall be the value of v. So therefore, placing that in terms of ijk, I'll have this as, because the coefficient in front of I is 0, I will ignore that, so I'll have 4j minus cos pi over 4k meters per second. Now to find the speed, you know the speed is the magnitude of that velocity, so I'm going to actually plug that in. You know cos pi over 4 is the same as root 2 over 2, so I'm going to have that squared, and then this is what I have 16 plus 2 over 4, and we're going to put that in a root. So add those and we'll have root of 16.5, which is 4.062 meters per second. Alright, therefore 4.062 meters per second is the speed when time is pi over 4 seconds. Alright, so next we're being told to find the distance from the origin when t is equal to pi over 4. So for part 2, first of all, we know that from integration technique, r shall actually be equal to the integral of v dt. And remember that the value of v we got with the value of t when it was unknown, it was actually this value right here. So we're going to have r being equal to that. Now when you integrate that, at the top I'll get negative cos 4t. This will give me negative 2 sin 2t plus 4t. Then this here will give me negative sin t plus a half sin 2t plus c. Now to find the value of constant c, I have to look for the origin where everything was when time is 0. Now according to the question, we are told that the particle started from rest at a point 2, 0, 0. So that means that the initial position was 2, 0, 0. So that means that at the start when t is equal to 0, r was 2, 0, 0. So plug that in, and this is what I have. Now remember that cos of 0 is actually 1. So I actually have negative 1 at the top. And then remember that sine of 0 is 0. So I have 0 times this is 0. Then this will also give me 0. Then this all will also give me 0. So I have negative 1, 0, 0. So I'm going to take this to the other side, and then I'll have this 2 and the 1 will actually add, and I have c being equal to 3, 0, 0. So therefore r shall actually be equal to this. Negative 4 cos 4t, negative 2 sin 2t minus 4t, negative sine t plus a half sine 2t plus that. So when I add the 2, this is what I'm left with. So the 3 will add to this, but because these are zeros, they'll actually stay as they are. So now I know r. So now when time t is pi over 4, this is what I have. I'm going to substitute pi over 4 wherever there is the t. Then when I do that, this 4 and this 4 cancel, and I'll be left with negative cos pi over pi plus 3. Here, when I actually see this will actually reduce to this, and I'll be left with pi over 2 here, as you can see. Then this and this will cancel, and I'll be left with minus pi. Then right here, I can actually see that everything will stay as it is, except this and this will reduce, and I have pi over 2 also right there. And this is what I end up with. So in pressing this in a calc, cos pi should actually give me negative 1. So I have negative 1 times this negative, which will actually give me a 1. So I have 1 plus 3. And then sine pi over 2 is actually the same as sine of 90, which will give me positive 1. So I have positive 1 times this 2, which will actually be equal to negative 2 minus that pi. And then here, right here, this will actually be equal to root 2 over 2. Then this is the same also as, now sine pi over 2 is the same as sine of 90, which is also equal to 1 times this a half. So eventually what I'm left with is this. So at the top I'll have 4, the next I have pi minus 2, because negative 2 plus pi can actually be arranged as pi minus 2. Then down here I can say at this we can find the LCM, and I'll have 1 minus root of 2 over 2. So now I can see that in the form terms of I, j, k, this is what I'll have as the position vector r at that time pi over 4. So now that I know that, I can find distance from the origin when time is equal to pi over 4 by finding the magnitude of that position vector, which is going to be equal to that. So squaring everything, this will remain as this 4 squared gives me 16. Pi minus 2 squared shall give me 1.303, and then this squared will give me 0.0429. So add those together and find the root, and the answer will be 4.165 meters, and that is the distance from the origin when time t is pi over 4. Alright, so lastly I have an exercise for you. These are numbers you can try out to get better at this section. So I've actually placed the answers right next to each question for you to compare with what you get to make sure you're actually on the right track. So these examples are properly researched on, they've been calculated and solved, and I believe that after you've solved them, you'll actually have a better understanding. So if you can, pause the video, copy the questions down and try each one out. So the questions continue. I have the next question, question 7, question 8, with the answers, and lastly I have question number 9. So try this out and get better. Thank you so much for watching. Thank you so much for watching this video. I hope the video really helped you. I hope the numbers were sufficient for you. If this video was of help to you, feel free to give the video a like, a thumbs up, and then feel free to share the video with all those that you can and help them out if the video really helped you. And then you can leave a comment down in the comment section for me, and I'll get time to reply to you. Thank you so much for watching. I'll see you in the next video.